In this session, we're going to deal with projectile motion, and we're going to do that by working through this problem which I have on the board. A ball is thrown at a velocity of 18 meters per second at an angle of 32 degrees to the ground. The ball is thrown from a height of 0.6 meters. If air resistance is negligible, how far from the point where the ball was thrown does it hit the ground? Assume that acceleration due to gravity is 9.81 meters per second squared. We've got a small sketch of that scenario, and we're going to work through this problem. So we need to determine where, after its parabolic motion, the ball eventually hits the ground. So from our problem, what we need to determine is that distance, S, from the point where the ball was thrown to where it eventually lands. There are three formulas which we're going to use to calculate that distance. Our first formula, S equals ut plus half at squared. Next is v squared equals u squared plus 2as. And the last one, v equals u plus at. Using the formulas we have here, we can easily determine the value of s using that formula. S equals ut plus half at squared. But what are the values that we know? We know our initial velocity, which is u. U equals 18 meters per second, but that's given at an angle. But we know that. V, the velocity at that point, we do not have. T, the time that the ball is in the air, we don't have that either. A, we're given that acceleration due to gravity is 9.81 meters per second squared. So in order for us to calculate that distance S, we can see from our formulas that we do have the value of u, which is our initial velocity, which is a component of 18 meters per second. We do not have the time that the ball is in the air, but we do have acceleration due to gravity A. So in order for us to use that formula to find the value of S, we need then to be able to determine the amount of time that the ball is in the air. So the first step we're going to take is to determine how long the ball takes to get from where it's thrown to the point where it reaches its maximum height. From that point, we'd then be able to determine how long it takes for the ball to fall from that maximum height to the ground. Adding those two components of time together, we then have our value of t, which means that we'd be able to use that formula to determine the value of s. So we're going to start by determining the amount of time it takes for the ball to reach its maximum height. We're going to use that equation there to determine that time, because we've got our initial velocity, and we know that at the maximum height, the velocity of the ball, v, is equal to 0. U in the upward direction is a component of 18, and we know it's 18 sine 32 degrees. Our acceleration due to gravity, is going downwards, and therefore it's opposing that motion of the velocity, so it's negative 9.81. So given these values, we can determine our value of t, and rearranging the formula, we know that t is equal to v minus u over a. Our value of t for that part of the flight thus becomes v is 0 minus 18 sine 32 divided by minus 9.81. And then putting that into our calculator, the value we get is 0.97 seconds. So we know it's taking 0.97 seconds for the ball from the point it's released to achieve its maximum height. And now that we've determined the flight time for the first part of motion, for the ball to achieve its maximum height, we can then calculate the maximum height h using our formulas. And we're going to use the first formula, s equals ut plus half at squared, using that value of time to determine the height h. But bear in mind that the value we get when we use that formula needs to be added by the height above ground from which the ball was thrown in order for us to get the actual height h. We'll put this to the side, t, and we'll call it t naught, is equal to 0.97 seconds. To calculate the value of h, we're going to use our formula s equals ut plus half at squared. Our value of u is motion in the vertical direction, which is 18 sine 32 degrees, and our time is 0.97. Plus half, our acceleration is acting downwards, force of gravity minus 9.81, and our t squared 0.97 squared. When we punch that into our calculator, the values we get are 9.25 minus 4.62. When we do the math, we get 4.63. Remember that that is the value above our 0.6. So the total value of h equals s plus 0.6, and that is 4.63 plus 0.6, which gives us our value of 5.23 meters. So we're just going to put that value there of h equals 5.23 meters. Having found this value, we're going to determine how long it's going to take the ball to fall from its maximum height to the ground. So it's going to fall through that distance of h, starting at a vertical velocity of 0 meters per second. In this case, our acceleration due to gravity is going to be at play, causing acceleration. We're going to once again use the formula s equals ut plus half at squared. So considering that drop, s equals ut plus half at squared. And we know our value of s is the value of h, which is 5.23 meters, is equal to our initial velocity at the top. Our vertical velocity is 0, so that becomes 0. Half our acceleration due to gravity, 9.81, times t squared. So we want to find the value of t. T becomes 5.23 times 2 over 9.81, and we want the square root of that. Punching that into our calculator, we get a value of t is equal to 1.03 seconds. So 1.03 seconds represents the amount of time it's going to take for the ball to fall through that distance of h. The total flight time for this projectile is going to be a combination of that flight time and that flight time. So our t total is equal to 1.03 seconds plus 0.97 seconds, and that gives us a total of 2.00 seconds. I'll put it to the side, t total is equal to 2.00 seconds. Now we move on to the last step, which is calculating the value of s. We're looking at that formula considering only our horizontal motion. At this point, we know our initial velocity, which is a component of that. We know the amount of time that the ball is in flight, which is 2 seconds. And we know that there's no acceleration in that horizontal plane. So we've got all the values we need to calculate s. So once again, s equals ut plus half at squared, and the value of s becomes 18 cosine 32 times 2 seconds. We know our acceleration is 0, so we resolve for that, equals 36 cos 32. Putting that into our calculator, the value we get is 30,5 meters. So our value of s is 30,5 meters.